Hello friends, hope you are doing well. Today I welcome you all for the online course on non-conventional machining. Our today's topic is electrochemical machining, in short ECM. In this lecture we are going to cover introduction of electrochemical machining, then working principle of ECM, then machine tool of this ECM, or we can say setup of this ECM. Thereafter we are going to see the process parameters, accuracy of ECM, and at the last we are going to see advantages, disadvantages, and some applications of electrochemical machining process. Let us see first part, that is the introduction about this electrochemical machining. Electrochemical machining is one of the newest and most useful non-traditional machining belonging to electrochemical category. Electrochemical machining is used to remove the material from the metal and alloy which are difficult or impossible to machine by mechanical machining process. This electrochemical machining process, it is a reverse of electroplating. Electrolysis has been successfully put to work in the areas like electroplating, electroforming, and electropolishing. The process of material removal by electrochemical dissolution was known as long back as 1780 AD, but it is only over the last couple of decades that this method has been used for the advantage. This is also known as contactless electrochemical forming process. The noteworthy feature of this electrolysis is that electrical energy is used to produce a chemical reaction. Therefore, the machining process based on this principle is known as electrochemical machining, that is ECM. This process works on the principle of Faraday's law of electrolysis. Now I will tell the statement of this Faraday's law of electrolysis. The first statement is the amount of chemical change produced by an electric current or the amount of substance deposited or dissolved is proportional to the quantity of electricity passed. The second statement is the amount of different substances deposited or dissolved by the same quantity of electricity are proportional to their chemical equivalent weights. So this is a basic principle behind our electrochemical machining. Now before going to working principle of electrochemical machining, we will see the electrolysis process. So in this figure I have shown the electrolysis process of molten sodium chloride salt. Now this figure shows electrolytic cell in which DC battery sends electric current through the molten sodium chloride salt. Electrons from the battery enter the melt at a cathode, and when the current is complete they leave the melt at a anode, returning to the battery. Then sodium ions, that is the Na plus from the medium, combine with the electrons which is available at the cathode and produce sodium metal which accumulate at the cathode region. That is Na plus electron which gives the sodium. Thus sodium ions are reduced, that is a reduction process involve the addition of electrons at the cathode. At the same time chloride ions migrates toward the anode and are oxidized. In oxidation process electrons are released to the chlorine which gives the half of Cl2 plus electron. In order to get a sustained flow of the current and to avoid the accumulation of ions at the electron, reaction must keep occurring at the electron to maintain electrical neutrality. Thus external circuit feeds electron into the medium at the cathode only. These electrons are consumed at the electron by the positive ions, or we can say cations, since they migrate to the cathode. and are released by the negative ions or ions of the medium at the anode. So this is the electrolysis process, okay, which is the basic of electrochemical machining. Now let us move for the working principle of electrochemical machining. So again, I have taken a figure, schematic diagram of the electrochemical machining for the reference purpose. So here in electrochemical machining, a small electric DC potential, that is 5 to 25 volt, is applied across the two electrodes. That is, one is the cathode and second is the anode. Anode will be act as a workpiece and cathode will be act as tool, and both will be immersed in the electrolyte. So here in this figure I have shown that during this electrochemical machining there will be a reaction occurring at the electrodes, that is at the anode and workpiece, and at the cathode or the tool along with the within the electrolyte. Let us take the example of machining of low carbon steel, okay, which is primarily a ferrous alloy mainly containing iron. For electrochemical machining of a steel, generally a neutral salt solution of sodium chloride, that is NaCl, is taken as an electrolyte. The electrolyte and water undergoes ionic dissolution as shown below. That is a potential difference. When potential difference is applied, then we will get the Na plus and Cl minus. As the potential difference is applied between the workpiece, that is anode, and the tool, that is cathode, the positive ions from will move towards the tool and negative ions move towards the workpiece. Thus the hydrogen ions will take away electrons from the cathode and from hydrogen gas, okay, which will give the H2 at cathode. So here I have shown in the reaction, okay. Similarly, the iron atoms will come out from the anode, that is the workpiece, and which will give the Fe plus 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 2 electron. Within the electrolyte, iron ions would combine with the chloride ions to form a iron chloride, and similarly sodium ions would combine with hydroxide ions to form a sodium hydroxide. Na plus plus OH minus will give the NaOH. In practice, FeCl2 and FeOH2 would form and get precipitated in the form of sludge. In this manner, it can be noted that the workpiece gets gradually machined and gets precipitated as the sludge. Moreover, there is a not coating on the tool, only hydrogen gas evolved at the cathode or tool. Now in figure 2 dissipates the electrochemical reaction schematically, and as the material mode takes place due to the atomic level dissolution, the machine surface is of the excellent surface finish will give, and that will be the trace free. Now here I have shown the figure of initial condition during the electrochemical machining, and after electrochemical machining what will get the final product. So in figure 1, that is initial condition, and second is the final condition. In the actual process of electrochemical machining, a cathode is a tool shaped, or that we can say a mirror image of the workpiece, and anode is the workpiece. Now during this process, a gap, that is a 0.05 to 0.7 mm is provided between the tool and the workpiece, and electrolyte flows through the gap at the velocity of 30 to 60 meter per second, and it completes the electric circuit. Normally electrolyte is pumped at the high pressure of 20 kg per centimeter square, that is 1.96 megapascal through the gap. Electrolyte must be circulated at the rate sufficiently high to the conduct current in between them and to carry the heat. Metal is removed from the workpiece by the dissolution process only. Okay. Now this is about the working principle. Now we'll move for the next part, that is the setup of electrochemical machining or elements of electrochemical machining. So now see towards the diagram. Here I have shown the setup. So in that we have the different important elements of this electrochemical machine. First is we require to provide power supply, that is a DC power supply. Then we need to have the electrolyte supply and it's a cleaning system. Then we should have the tool, that is the cathode, and tool feed system also. And important, that is the workpiece, that is anode, and workpiece holding system. So here you can see all the elements I have shown. Now we'll see each element in detail. First is the power supply. So the type of power supply should be DC. Then we have to maintain the voltage 5 to 25 volt. Then we have to maintain the current, that is 50 to 40,000 ampere, and you can maintain the current density in between 20 to 300 ampere per square centimeter. This is about the power supply. I will discuss the electrolyte. Now common electrolyte used for this electrochemical machining are sodium chloride, sodium nitrate, sodium hydroxide, sodium fluoride, or you can use sodium chloride, potassium chloride, and sulfuric acid also. This solution on a reaction produces insoluble component, okay, in the form of the sludge. Now the main function of this electrolyte in this electrochemical machining, that is the first is it carries the current between the tool and workpiece. Then it removes the products of the machining and other insoluble products from the cutting region. Again it dissipates heat produced in this operation. The essential characteristic of this electrolyte include the good electrical conductivity, non-toxicity, and chemical stability. Okay, and the electrolyte should have the low viscosity and high specific heat. Okay, normally high velocity flow over the electrolyte surface is one of the key factor of electrochemical machining. Now we'll see the tool, that is the cathode. The most commonly used tool material are copper, brass, titanium, copper tungsten, and stainless steel. When electrolyte is made of salt of sodium and potassium, titanium has been found to be the most suitable tool, where the electrolyte has a tendency to ionize the tool, as in case of the sulfuric acid. The other tool material are aluminum, graphite, bronze, platinum, and tungsten carbides. Okay, the accuracy of tool shape directed affected the workpiece accuracy. Electroforming and cold forging are two methods of tool shaping. Okay. The general requirement of tool material in electrochemical machining are: it should be a conductor of electricity, it should be rigid enough to take up the load due to the fluid pressure. Okay. It should be easily machinable to make it in the desired shape. This is about the tool. Now we'll move for the workpiece, anode. Workpiece should be conductor of electricity, so it is almost limited to metals only. The chemical properties of anode, that is work material, largely govern the material remote rate. Okay. This is about the components of electrochemical machining setup. Now here I have shown some accuracy related point. Okay, there are a number of factors which govern the accuracy of the part produced by this electrochemical machining. The major are: the first is the machining voltage, feed rate of the electrode, that is the tool, then temperature of electrolyte, concentration of the electrolyte. Okay, so under ideal condition with properly design the tooling. Electrochemical machining is capable of holding tolerance up to plus minus 0.02 mm. Surface finishes in this electrochemical machining we can achieve in between 0.2 to 0.8 micron. No burrs and sharp edges are left on the workpiece during this electrochemical machining. Now let us discuss some applications about the electrochemical machining. The first application is it is used for the high accuracy duplication purpose because there is no tool where it can be used repeatedly with a high degree of accuracy. It is commonly used on thin walled, easily deformable and brittle material because they would properly develop cracks with conventional machining. It is used in machining of hard heat resisting alloys also. It is used in cutting cavities and holes in various products, machining of complex external shapes like that of turbine blades, aerospace components, and machining of tungsten carbide, as well as nozzle of alloy steel can be produced using this ECM process. Any conductive material can be machined by this process. Now here I have mentioned some advantages. The first advantages is very accurate. Then this ECM is relatively faster than the other. Then it can be machine hardened material than the tool. Extremely thin material can be easily work uh, without distortion. Tool wear is nearly absent and we will get the better surface finish using this electrochemical machine. Now we'll discuss some disadvantages. First is the high energy consumption. Non-conductive material cannot be machined, and corrosion and rust of electrochemical machining can be hazardous, but preventive measure can help in this regard. So this is about the our today's lecture. Thank you very much.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.